Welcome to tutorial number 3a, and in this series of tutorials we're going to discuss an overview of energy modeling and then how to go about starting your own energy model using SketchUp, Legacy OpenStudio, EnergyPlus, and Excel. And I'm going to walk you through all the steps involved. The first thing you should know and understand is that what we're about to do is a bona fide real building information model. This is a set of geometry that is associated with certain characteristics. For instance, in this screenshot here, you can see that this window has in it associated a name, a surface type, a construction type, a boundary condition, etc., 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 along with all of the geometry that's associated with it. And that is a real building information model. There's information embedded in the geometry. So I'm going to show you a number of different ways of inputting this information. Before we start on that, though, I think I'm going to give you a little bit of an overview of what you're going to do. First, we're going to look at a thermal zone and the context for that thermal zone. And we're going to look at the geometric input that's required, because it's significantly different than what you would traditionally think of as an architectural model. Then we're going to look at internal loads and schedules, then envelope characteristics, and finally we're going to look at HVAC systems and schedules and renewable energy. We're going to use OpenStudio to do this, and it's important that you understand the context in which you're using OpenStudio. So OpenStudio is a plugin to SketchUp. It's used specifically for building information modeling related to EnergyPlus, which is a simulation engine. And what OpenStudio does is it translates some of the geometry and building information into a format that EnergyPlus reads. So the workflow is going to go something like this. We're going to start with SketchUp and input some geometry, and then using the OpenStudio plugin we're going to translate that into building information. And in that workflow, the SketchUp file type is an SKP. The OpenStudio file type is an IDF. And it's important that you remember the differences, and I'll show you graphically how you'll know that it's different. But basically what we're doing is converting SKP to IDF. And then in something called the IDF editor, we're going to continue to edit that building information model. It's going to be a little bit easier within the IDF editor to do some quick changes. And then from that IDF editor, we're going to simulate the thermal run, and in fact the entire energy run. And the simulation engine that we're going to use is EnergyPlus. And as it does that, EnergyPlus is going to output a whole bunch of files. Among those files is going to be a CSV file, a comma-separated value file, which is going to give you all of the outputs for your simulation. And then we're going to import that CSV into Excel using another template that I've set up. And then we're going to save that as an XLSX file. So hopefully that workflow is clear. If not, it will become clear as we go through it. So first I want to start with the difference between an architectural model and a thermal model. You can see here I've got an architectural model of Worcester Hall, and for this set of examples I'm going to just simulate the room that we've been in, the computer lab, which is over on this corner on the second floor. Now, with an architectural model, depending on what you're trying to represent, you'll probably show materials, you'll probably show wall thicknesses, sometimes even glazing thickness, you'll show the shading devices, sometimes you'll map materials on like this in order to see the concrete forms, interior partitions, sometimes workstations and people, sometimes ducts. A thermal model is quite different. Rather than modeling all that three-dimensional geometry, A thermal model is basically trying to show exactly what the envelope or the boundary conditions are for a given amount or volume of air. It sounds like a weird concept, but this is going to be clear in a second. Think of it like a vessel that's holding all that air. And into that air, there are different thermal flux or differences, such as sun or cold or internal heat. And so what you're essentially doing in the thermal model is heating up and cooling down that volume of air. So there's a very different approach to modeling that than there would be to modeling a three-dimensional architectural building. I'm going to go through that process now, and hopefully this will be clear relative to the computer lab, and then you can use a similar process to develop the thermal model of your case study. So I'm going to erase this. I'm going to just make a new file here, and so I've got a blank SketchUp file, and it automatically comes in with this person. I'm going to delete him by pressing delete, and now I've got a blank file. And there's a few things you should know about SketchUp, just how to model. It's a unique type of program. So over here on the left you see a bunch of different tools, and we're only going to use a few of them. We're going to use this rectangle tool, and we're going to use this push tool, and that might be most of what we use. And I'll show you a few other tricks a little bit later. So for instance, if I want to model a rectangle, I can pick my rectangular tool, drag down here, or place it here at the origin, click once on left click, and then drag out and click again, left click. And now I've got a rectangle. I'm going to erase that and do this again and show you I can do that, and you see in the bottom right here it gives you dimensions. So you can actually input those dimensions like 20 feet, comma, 40 feet, comma, enter, and you'll get a rectangle with those dimensions. If I select this push-pull, then I can extrude that volume, and I can extrude it to a set amount. I'm going to press Ctrl-Z by extruding it and then pressing, say, 10 feet or 20 feet or 15 feet. And you can keep changing this as long as you haven't changed to a different tool. So this is a nice feature. You can kind of do an action and then make it a little bit more precise as you go. That push-pull tool also works in sections, so I can push-pull this way or this way. And in addition, I can, if say I want to draw a line, I can draw a line vertically like so, and then push-pull a part of this in order to extrude it out again. And I can keep doing that kind of infinitely, which is both good and bad, I think, you'll see, to get different surfaces. So all that is fine. That's pretty much most of what you need to know in order to get familiar with SketchUp. Now, what you all are going to need to do is decide on an analysis zone. Oh, actually, before I go into that, I should explain. If I save this file now, file, save as, and I'm going to just save this to my desktop as tutorial 01. This is now an SKP file. Ignore that. It's you can see up here, tutorial01.skp. Fine. SKP stands for SketchUp. So that is its own geometry, and it's just SketchUp. It doesn't have any building information associated with it. Now, in order to associate building information or create a building information model using OpenStudio, I need to specifically use the Legacy OpenStudio extension. And to access that, I can go to here to extensions, and then there's a whole bunch of different tools to use, and I'll explain those in a second. You should also have some toolbars here that automatically come up. If they're not up there, then go into Window, Preferences, and make sure that Legacy OpenStudio is checked here. And if someone has clicked them off, like so, you can go into View Toolbars, and in Toolbars you can find the Legacy OpenStudio here. There's this one and this one, and restore them. So now it's very important that you keep these separate from these, and in fact I like to keep these Legacy OpenStudio toolbars up on the horizontal up at the top, and then the SketchUp tools on the left, so I don't confuse them. And so these are separate. So I can open a EnergyPlus input file, IDF file, from there, and I'm going to open the 00e plus template that's on the assignments website, and you'll see that this is going to import a set of geometry. It also always comes up with this file does not contain default construction names. If you want to set these before drawing new geometry, and I just say no. In this case, it's also telling me that it has not been versioned up to 8.5. It's at 8.4. And I'll see if I can change this before I distribute the template file, but if not, it's okay. So now you see that I've got this geometry, and actually let me move this. I'm going to move this by selecting it. So I'm going to drag it and move this by going to the Move tool. I'm going to move this away from my SketchUp geometry. So now you can see that I've got the SketchUp geometry I made before, and then I've got some geometry that's associated with that template. And these are different. This is the SKP file, and this is the IDF file. So this is a really difficult concept for a lot of people to understand, and it's really important that you not confuse the two. This is made all the more confusing by, if I were to save this file as a SKP, I'm going to save this as tutorial2.skp, and SketchUp is not that smart. It doesn't know that this is its own building information model over here. And so I'm going to, just to make this clear this, and I'm going to open that tutorial2 file, and you'll see that my OpenStudio objects come back, and it's very likely you're going to get all sorts of weird errors, which I'm seeing right here. And so you never really want to save the IDF files as SKP. Always keep the two separate in your head. So I'm going to delete these, all the objects associated with that IDF. I'm going to re-import the IDF here. And that is going to bring those back as they were. Great. So I've got here this theoretical zone, which you can see right here. It's got a roof, walls, and a window. And it also has 3 PVs back here and 1 big shade, which is a tree. So I'm going to explain all these different components, but should know that these components are all going to come with that template file. I'm also going to just erase the SketchUp file, or SketchUp geometry, so you can see a little bit better what's going on. Now, The first step to making your thermal zone for your model is to scale it correctly to your building. And there's a few different ways of doing this. I'll show you a couple. The first thing to do is to either have, I think all of you have plans of some sort that are dimensioned, and make those plans, which I think are all in PDF format, into PNG files. So I'm going to open here a plan of Worcester Hall so you can see what I'm talking about. This is plan of Worcester Hall, and the computer lab is right here. And I'm going to save this as oh shoot, not a save as. I'm going to export it to an image, a PNG, and I'm going to save that here. I've actually already done it, so you'll see this in a second. I'm going to close that, and I'm going to then take this PNG file that I just made and drop it onto the canvas, just like that. And as I do that, that comes in unscaled. That's just some random scale that I've got there. Now, if I zoom in here, you can see, oh, actually you can't see, I've got a dimension here and a dimension here. And if I go to this one maybe, you can see that that dimension is 28 feet between A and B, and 28 feet between 17 and 18. And so I want this to be 28 feet. Now, if you've got metric, that's fine. I'll show you how to change the units. You go to Window, Model Info, and you'll get this dialog box. Go to Units, and here you can change to from inches to meters or metric by going to decimal and then changing to metric, either meters or millimeters. I prefer millimeters, but I'll leave it up to you. And then you can just click X, and now it will be in the model will be in meters. I'm going to change that back to inches and show you how to scale this. So I'm going to click on a line, and I'm going to try and align this line as best I can to my A-axis. And a shortcut, by the way, for stopping a command is to press Enter. Or sorry, not Enter, spacebar. And now I'm going to take that and move it, and the shortcut for move is M. That's what I'm going to do here. And to move something, I can click on it, and if I press Control while I move it, I can copy it. So if I press Control again, it just moves it. If I press Control again, as a toggle, it copies it. And now I want to copy it 28 feet away. You can see on the lower right, I'm now about 4 foot 3/4. So I'm going to type 28 feet and press spacebar, and you can see here's my 28 foot mark. So what I want to do is scale this dimension to that 28 feet. And I can do this by clicking on this scale, or S. The shortcut key is S. And I want to scale it by the diagonal, because that's a uniform scale, like so. Actually, there's a better way of doing this. I'm going to go back and show you the better way, which is to explode this object. I can explode it by right-clicking on it and explode like that, and then right-click and say Make Group, like that. And with that, now I can double-click and click on an edge, and then move that edge to align. I can align, by the way, by pressing Shift, and that constrains it to this red axis. So I'm going to constrain it there. And now, when I scale this, I'm going to go back to the scale command. It will stay in line with that left-hand side. So I can scale this now to be somewhat close, I hope, to that second line, and I'm going to try again here. Oh, that was not a bad guess. So I got a little bit, it was a little bit over. So I'm going to press S and bring it back just a tad. And that looks close enough anyway for what we're trying to do here. So now I've got a decent plan to use as a guideline, and I can erase these. So another way of measuring, by the way, is to use the tape measure, which is right here, and I can measure from now A to B. If I hover over, it's 28 foot 2 1/8. Let's say that's good enough for what we're trying to do here. And now what I want to do is fit this zone. It's very important that you work from the zone that I gave you rather than don't delete this zone and try again, because it's named in particular ways. Same, by the way, with these PVs. Please do not erase those PVs. So I'm going to move this zone to this corner here, and then I'm going to push-pull this face. So I'm going to double-click, press on push-pull, and I'm going to push this until it's in line. Now I just realized that, oh, I was a good guess too. When I double-clicked, the background went to gray, so it was difficult to see what was going on. And so another way of doing this would be to make a line at that edge where I wanted the that boundary to be, and then I can snap to that line. So I've got that length, and now I need the other length. And to do this, I double-click again. Or I'll show you this method. So I want it to be there, and double-click, and now I realized when I extruded that in, I got this extrusion around the window, which is not really what I want. So I'm going to delete this side of the window. Oops. And I'm going to delete the window as well. You'll see it's fairly easy to make new windows. So now I've got my room. Just going to make sure that that's, yeah. I've got the full extent of my computer lab now here. And I didn't want a window on that side anyway, so we're fine. Where we do want the windows are on this side and this side, but we don't know exactly where. What I need for that is elevation drawing. And I have one here in my documentation, an elevation of the entire north facade. And again, I just dragged it onto the canvas, and you can see here that it's the entire facade. So it's kind of more than we need. I'm going to rotate this by going to the protractor tool here. The shortcut is Q, and rotating it 180 degrees that way. And then I want to rotate it up in plan. To do this, I'm going to click on a corner, and as I'm going to keep the left click down and drag in the axis that I want to rotate. So I'm going to drag this way in, and then release, and now it will rotate around that axis. So I want to do this 90 degrees. I'm going to press 90 and enter or space, and now it's standing up, which is great. Now I need to scale it and crop it. So I'm going to do the same process I did before. I'm going to right click, explode, right click, group, and then I'm going to crop this to the boundaries of the computer lab, which are just that small. And hopefully this will still have enough resolution to see what's going on. And I'm going to scale this up so that it's a little bit easier to see. I don't know if these are the same grid lines. I think they might be. So we might be able to align them. I'm going to try that by cropping this right to the grid line and then aligning it to that corner, and then trying the same thing on this side. And now if I press S and scale this to something like that. Oh, I see it wasn't aligned. Sometimes that can be difficult when you're dealing with three-dimensional space. And a good method of making sure that you're aligned is to go in order by axis. So if I first click on there and then go towards the zone and press Shift and then align to the zone, and then come around the other way, click on that edge and go towards it in the red axis, and finally go and click and go down to on the blue axis. Then I will have ensured that they're aligned. And so I'm going to make sure this is close, and it is, and it looks like this is aligning nicely. So I'm going to assume that the top of the ceiling is somewhere around there, and the floor is somewhere around there. And that would be, how tall? 13 feet. I think that's about right. I think it's probably about 14 feet. So we're close. And now I'm going to align this vertically like so. And I want to align my zone as well. So I'm going to double click into the zone, press P for push, and then align the roof to that edge. So what I've made now is the boundary of my air. Remember, this is really an air model, and so the volume of air is contained by this box. And now I want to add openings to the box. One thing that's important to note about openings is that they are considered children of a parent surface. So the way that EnergyPlus finds the openings in the wall and knows the orientation is by locating first the wall itself, and then locating what is a child of that surface. So as a result of that, in order for it to know where a window is, the window must be completely coplanar, that is, in the same plane as the wall, and it can't extend to the edge of the wall. These are two rules that can't be changed. So you always, always, always must have a window within the wall. And actually, this is kind of neat. When you draw a window, it will automatically make that blue, so you know that it's a window. And if you were to draw it from the edge, so like this, it would not make it blue. So you know that that's a mistake. That's bad. And so I'm going to delete those lines because we'll get lots of strange errors if we do that. So we want to align this window to the proper vertical axis. And the best way that I know how to do this is to make some alignment lines. And so the way to do this is to, I'm going to take this and move it just slightly out so I can see where the top and the bottom is. I'm going to use my tape measure. My tape measure is a good way of drawing guidelines. So if I click on an edge and then move vertically, it will create a guideline. See that dotted line there? And so if I press Shift, and then so it stays vertical, and then go over to the edge where my window head is, I can drop a guideline at the head. And I'll do the same thing at the sill down there, and then I can move my window to snap to that line, like, oh, I didn't grab from the edge there, like that. And then I can delete these guidelines over there. So and then I want to do the same thing to this edge, and the way I can do this is also I press T for tape measure and go up, press Shift, and then I can align it to that edge again to there, and then make a rectangle in that edge. Now I can come back and delete those. Whoops, I don't want to delete the zone. I want to go in and just delete those guidelines. Now these windows are actually discrete windows that are only this big, and then there are these fins between them that are concrete. So I guess I'll make 3 discrete windows here, and I can either use my plan or my section here to do that, and I can use the same method with guidelines to drop in the edges of those fins so I know where the window should go. So I'm going to go ahead and make this middle window first by aligning these edges with my guidelines, and now I can copy that window to the other 2 positions here by double clicking on it, clicking M or move, and then pressing Control to do it from the other side to copy them. Now this one, the way I've done it, looks like a very close fit to this edge. And I want to really make sure that it's not touching the edge. I might even nudge this over a little bit just to make sure. Yeah. So you get the idea, and I need to do the same process along this facade here. So I'm going to do that real quickly here. I'm going to add guidelines here, here, and here. I guess I'll do one more here. And adjust this window accordingly. And now I want to copy that 1, 2, 3, 4 times. So I'm going to double click on that again, press M, Control, click there, and then I'm going to do 4x. See that in the bottom right where it says 4x? Right here. And it should, no, it never does it when you want it to. Should I'm going to double click on the window, press M, Control, and then press 4x. See that in the bottom right? And it copies it 4 times, which is a nice way of arraying a window. I'm going to do that again here. So now I've got my line of windows on the west side of the building. Okay, so now I've got a thermal zone with windows in it, and that will cause heat gain and heat loss. This is a good time to save. In fact, I probably haven't been saving enough. It's really important that you save because OpenStudio has a really bad Control-Z functionality. It often will not let you go back, and I really encourage you to save as much as possible. And there's a good versioning technique I use that'll help you to do this. I'm going to click on this Save As button, and in this folder I'm going to create, you see I've started this numbering system. This is going to be 0, 1, and I'm just going to name what I've done so far. So I'm going to call this 01 underscore base geometry.idf and save it. And really, these are very small files, so you can keep saving versions after version after version and just keep that numerical sequence so that you can always go back by going to a former file. It's never a bad idea, too, because there's some strange things that go on with OpenStudio, to clear the geometry and reload it in order to make sure that everything you did was stuck, I guess, or saved properly. So I'm going to click on this new EnergyPlus file, which is going to get rid of all of my old EnergyPlus geometry, but you see the SketchUp geometry stays. Now I'm going to open the 001 base geometry.idf, and hopefully it will import it correctly right where it was. I click No, and voila, it's there. That's a great sign. So that's a good place to leave this tutorial. And in the next tutorial, we'll look at adding context, such as trees and other buildings, to this model.